Hello world. Sound familiar? Oftentimes, that's the first software program that anybody writes when they're learning a new programming language. And that's exactly what we're going to do today. The tools that we're going to use are the Vivado HLX edition, version 2020, the Xilinx Vitis tool for the application itself, an Avnet minized board. And so what we're going to end up with is we're going to have a Xilinx Zynq FPGA with an ARM Cortex A9 that's running this Hello World program. And that text string is actually going to end up on the console terminal of the Vitis tools. So without further ado, let's get moving. The first thing I'm going to do now that I have Vivado open is I'm going to create a project. So I'll left click on that. And that's going to bring up a dialog. And here we go. So create new Vivado project. We'll go ahead and click next. We'll go ahead and call this Hello World minized. All right, and we'll go ahead and leave that in the default location. We're going to go ahead and leave this default setting as well. It's calling it an RTL project. In our instance, we're actually going to be instantiating a block and a block diagram, so it really is a hybrid kind of project, but we'll leave it that default setting. Now here, the tool is looking for us to select the specific part that we want to target our design for. Now what's nice about Vivado is it's what they call board aware. So if I click on the board link here, it shows me a bunch of different development boards that have Xilinx devices on them. I'm going to be using the Avnet minized, so under the vendors, I'm going to click the down arrow, select Avnet, and there's my minized board. So I left click on that and go ahead and click next. Now you may have a different board that you're using. Go ahead and select what you're using. The process that we're going to go through will be the same. There'll just be some minor details that are different. So under the project summary, you can see that it's got the information on the board and the part in the part family and the speed grade. Let's go ahead and click finish. Now, some aspects of this project run fairly slowly, and you don't really see anything changing on the screen, or if you do, it's just this kind of green bar going back and forth. When it comes to things like synthesis, the implementation, compiling, things that are computationally intensive, I'm going to be snipping out portions of the video simply to keep the size of the file more manageable and the duration of the demo more manageable. Um, I have done a trial run of this, and it can take up to 40 minutes, and that's way too long for this kind of demo. So if I do that, cutting out of the compile times, I can cut that down to about 20 minutes. So hopefully that'll be okay with you guys. So here we are. On the left side here, we have our flow navigator. What I'm going to be doing is I'm going to be creating a block design. So let's left click on that. I'm going to leave these defaults just because there's no need to change this for the demo purposes. So click OK. All right, I notice that we have this new window over here, and there's a diagram tab. So there's three ways that we can actually add a block. There's a plus sign up here, there's a plus sign in the middle of the canvas, and then if I right click on my mouse, there's also the add IP entry in the pop-up menu. I'm going to go ahead and use that one, so I'll left click on it. And here we have an IP catalog that pops up for us. Um, I'm going to be instantiating the Zynq processing system, so let's go ahead and start to type in Zynq, and there we go. So the Zynq 7 processing system is what we're looking for. I'll double click on it. All right, and there's our Cortex A9. Now notice that we have this green stripe here. It's saying there's a designer assistance available, run block automation. This is kind of a nice feature that Xilinx has added to Vivado, and what it will do is if there are certain aspects of the IP that you're utilizing that need to be configured, it can automatically configure it for you. You can still do it on your own if you want to. Um, Additionally, in this instance, I only have one block, but if I had multiple blocks in there, the block automation could automatically interconnect those blocks, things like resets, clocks, buses, etc., for known IP structures. So I'm going to go ahead and run the block automation. And it's telling me, okay, there's only one block that needs to be configured here. I'm fine with all these default settings, so I'm going to go ahead and click OK. All right. The next thing I'm going to do is kind of a design rule check kind of thing. So if we look up here, we have an icon that's called Validate Design. I'm going to left click on that. Vivado's happy with everything there. The next thing we need to do is to create an HDL wrapper for this block. And we need to do that because the next step of this process is to synthesize the design. And the synthesizer wants to see HDL code at the top level. So I'm going to go ahead and create an HDL wrapper for this block. So I'm going to go over here to the Sources tab, click on that. Design one is my block diagram. I can tell, I know that automatically, but if you look at the file name, it's design1.bd, where the BD stands for block diagram. So let's go ahead and right click on that. And notice my entry here, create HDL wrapper. Let's go ahead and click on that. I'm going to go ahead and leave this default setting, let Vivado manage the wrapper on auto update. So anytime there's a change, I don't have to manually update the wrapper. Vivado will take care of that for me. So left click on OK. It's not quite done yet. Notice it says it's updating here. All right, so now under design sources, notice that the top level is this design one wrapper. Here's the name design1wrapper.vhd, so it's a VHDL file that has a component instantiation, and that component that's instantiated is this processing system. If I click on this little arrow, it'll show me the hierarchy associated with it. So one more step we need to do before we can go to the synthesis stage, and that is we need to generate the output products. So let's go ahead and select our block diagram. We right click on it, and down here it says generate output products. So we'll select that and generate. All right. And we can see we're updating still up here. So let's wait for that. There we go. Oh, no, we're still working. Look up here in the right corner. Okay, so the next three steps are synthesize, and then run the implementation, and then the write bitstream. So the synthesis actually will take the net list associated with and all the output product files. So the synthesis run will take all the files that are in the project, and it will create a flattened um, net list that instantiates all the IP that you either have instantiated in your block diagram or you have inferred in your HDL code. Once you have that flattened design, you run the implementation. So the implementation stage takes all the primitives that were instantiated in your flattened netlist, and it maps those into the primitives associated with the specific device that you chose when you created your project. Um, Place and route is also done, and this is one of the most computationally intensive tasks that will occur in this part of the process. And then the last stage is to write out the bitstream, and that's the file that will be used to program the part. So you can run each of these individually and look at the output at each stage. Alternately, you can just jump right to the end. That's what I'm going to do. I'm just going to click on Write Bitstream. It will realize that the previous steps haven't been completed, and it will go ahead and complete all of those and run the Bitstream program. So um, I'm going to go ahead and do that, and once it's done, there's one more step, and then we'll be ready to go over and start taking care of the application on the firmware side. So let's come over here to the Flow Navigator. Here we see Generate Bitstream. I'll left click on that. Okay, and we'll go ahead and run that. All right, here we are. It's completed all of the steps, and it's asking us if we want to open up the implemented design. I don't really need to do that. We'll tell it we'll view the report. I'm not going to do that. So we've done the capturing of the behavior and the blocks that we need in our design. We've run the synthesis, we've run implementation, we've generated the bitstream. The next step is to actually export that file. So let's go to the file pull down, select export, and we're exporting hardware here. All right, we're going to have a fixed platform. We're going to include the bitstream. Okay, that's the hardware specification for the software tools. What are we going to call this? Design one wrapper is fine. It's going to be in our Hello World minized directory. So let's go ahead and click Next and finish. Okay, looks like we're done with that export. The next thing to do is to actually open up the Vitis tools. So what we've done so far is we have selected a device. We've selected this IP that we wanted to utilize in that device. We've run through the synthesizer, we've run through the implementation, we've generated the bitstream, we've exported the wrapper. So now we go to back to the tools pull down here, and we launch the Vitis IDE. Okay, that's not quite the workspace we wanted. Here's the one, Hello World minized. Select that folder, and we'll launch. All right, so here's Vitis. We're going to go ahead and open this up. We're going to grab the file pull down. The first thing we have to do is create our hardware platform in the Vitis environment. So let's go to the file pull down, new, and platform project. Okay, we'll call this the Hello World minized platform. And click on next. All right, So we need to find our XSA file, and here we go. It's in our work directory, design1wrapper.xsa. We'll select it, click OK. Our operating system is a standalone, so we're not running any kind of Linux here, and we're running it on the Cortex A9. So let's go ahead and hit finish. Okay, so here we are. One of the things that we have to modify um, is the way that the hardware interprets standard I/O. Um, and right now, um, the hardware expects the standard I/O port to be on UART 0, but the board design for the minized board has the console um, attached to UART number 1. So we have to make that change. So we'll go to the board support package, modify, and go to the standalone. So here you can see standard in and standard out. They're tied to the processing system 7. UART 0, we have to change that. So there's UART 1. Here's UART 1. We say OK. So what we're actually creating here is we're creating all of the firmware files that the application project will need to know how to interface to the different resources that we're using in our hardware project. So we just ironed out the difference on the standard I/O so that it's showing up in the right place on the right hardware pins. Okay, so the next thing that we can do is to go ahead and compile that project. So we'll right click on it and build project. So now our compilation is complete. Now we need to create the actual firmware project that implements Hello World. Everything that we've done so far is just configuring the hardware so that we have something to run the Hello World application on. So let's go ahead and go to the file pull down, new again, and now we're going to create a new application project. Click on next. And this is the correct platform that we want to use, so we'll click next. All right, and this is our application. So this is Hello World. So now we're talking about creating the actual firmware that will run on this Cortex core that's inside that Xilinx Zynq device. All right, that's the correct domain. Now it's going to pull up some templates for me. All right, so there's my Hello World template. So I'm going to select that, click on Finish. All right, here we are. If we want to take a quick peek at our source code, here's helloworld.c. Pretty simple. All we do here is we're printing out Hello World and print successfully ran Hello World application. So we've created all the files that we need to execute that. So we'll right click on the project, the application project this time, and we'll build it. All right, there we go. We're done with the compilation. We can go ahead and do one more thing before we're ready to run. Although let's go ahead and fire up the debugger. So we'll right click on the application, launch the hardware. All right, we're in the debugger now. I've got my board plugged in. You can't see that, but you'll have to take my word for it. Programming the device. See the little blue light come on. I know it's programmed correctly. And it's patiently waiting to run. So um, down here we can see the Vitis serial terminal, and this is where the information is going to get printed out. Um, I have to make sure that's correctly configured for my PC here. So I'm going to go ahead and click on this little plus sign. Um, the baud rate I know is correct. And what I've got to do is I've got to select the port, because what we've got here is we've got a USB to serial bridge. So out of the ARM Cortex A9 is a serial port, but what actually goes into the laptop um, is USB. So we got to make sure that's configured correctly. Click on OK, and we're now ready to run. So I go ahead and I click on the play button, and there we go. Hello World successfully ran the Hello World application. So what we've done there is we have created a project using Vivado. We've instantiated that Cortex A9 device. We could have instantiated other IP blocks. We could have created our own HDL file. Um, we ran through the synthesis, through the implementation. We wrote out the Bitstream. Then we went over into Vitis, where we imported that file from Vivado. We created the hardware-specific project and compiled it. Then we created the application that used that hardware specific project, and we added that template for Hello World, and then we ran the debugger and we got the thing to go. So what we've done here is we've demonstrated that our installation of Vivado is correct, our installation of Vitis is correct, our our Avnet minized board is working, and you've got a kind of a walkthrough of the process that you have to go through from start to finish for creating a simple um, application running on a Zynq processor in the Xilinx environment. I hope you guys enjoyed that. I certainly enjoyed putting it together for you, and if you have any questions, please don't hesitate to let me know. Thank you.